So the title of this page is Hybrid Model of Artificial Neural Network, Cuckoo Search for Irradiance and Load Forecasting. The authors are Rafael Ferraz, Renato Ferraz, Augusto Medina, and Jussara Fardin. This paper was developed in Federal University of Espírito Santo, UFS, in Vitória, Brazil. The introduction. So forecast is an essential tool that can aid management in its decision-making process. With regard to the electricity sector, many papers have been developed with the purpose of reducing time series prediction error. So we have some time series, for example, intermittent source and the load profile. The first one, we have the intermittent source, such as Irradiance, have been the main research targets due to the increasing penetration level of distributed energy resource, the DER. And the load profile has shown a gradual change, mainly due to the increased integration of terminate source in the electrical system in recent years. Many recent papers have used the artificial neural network, the ANN, as the main prediction tool. So here we have the main gap of this paper that is related to the ANN parameters. So a good selection of some ANN parameters is essential for lower errors. And the most important parameters that we have in the ANN are the ANN inputs and the number of neurons in the hidden layer. However, there is not a universal approach adopted for all prediction works to select the parameters. For example, for the ANN inputs, some papers selected this parameter, the historical data, based on the autocorrelation function, the ACF, and based on the partial autocorrelation function. They just observe the significant lags and select them for the ANN, for the artificial neural network. And other papers select the historical data, the ANN inputs, based on tests. And for the hidden neurons, some papers use empirical equations, but others, and most of them, select the hidden neurons based on tests. So the purpose of this paper. The forecasts of the irradiance and load time series are performed using a hybrid model of ANN and modified Cuckoo search, the CS algorithm. The modified CS was applied in order to select the ANN parameters. The results were compared with applications of particle swarm optimization, PSO, and trial and error in order to validate this methodology. The main contributions of the paper. The first one, a novel methodology based on the application of the modified CS optimization algorithm in order to select the smallest amount of both AN parameters. There we have the AN inputs and the hidden neurons. And this methodology is suitable for several applications in smart grids. Moreover, another contribution is related to the simulation time. So we have a significant reduction in the simulation time for selecting the ANN parameters. So this paper is divided, the methodology is divided in two stages. The first one is about the data preprocessing, and the second one is the forecasting. The first one, the data preprocessing, it is based on the reducing deterministic variations and normalizing the data. And each time series has its own characteristics. Thus, it is not possible to reduce the deterministic variations applying the same method for all time series. For example, for the irradiance, it was applied 3 steps. The first one, the night time of the irradiance data were eliminated, as they are null values. The second one, the every daily curve of the irradiance data was obtained for each month. So the detrained model were applied to fit to each month curve, as we can observe in reference 5, and the residual data was normalized and applied to forecast. For the load database, we know that the load profile is different from the irradiance data. As we know, we have variations during the year, so the load profile can increase or decrease in a year. So in this stage, we want to obtain the PD trend of this equation 1. PD trend is the data of the load profile without the deterministic variations. And if we multiply this PD trend with 4 coefficients, we obtain our first P, that is the original data. And the coefficients, we have the first one. It is the days of the week. The second is about working days or weekends. The third is about the hours of the day. And the last one is the day of the year. And then we have our residual data that we will normalize it and apply to forecast. Now the forecasting stage, the authors propose to apply the CS algorithm to obtain both ANN parameters in order to minimize the objection function, which is the forecasting mean absolute percentage error. In addition, it is important to mention that the threshold for selecting historical data as input of the ANN was determined with the aid of the ACF, verifying the significance of past values. The CS algorithm has been modified, and the modification is presented here. We have in the figure part of the algorithm that was modified. So the modified part of the algorithm consists of observing the MAP variation of Fi and Fj. The Fi is the actual iteration, and the Fj is the last iteration. So we observe, we compare both, and if the error variation was less than a certain value z, the best result should be the one that presents the smallest amount of historical data and number of neurons in hidden layer. So then we compare these results with trial and error and with particle swarm optimization, the PSO. So it is possible to compare the selection of the ANN parameters and the simulation time. So in here, as for the results, we have the irradiance data. In black, we have the original data. In orange, we have the pre-processed data. And in the figure in the right, we can see the ACF of the original data and the pre-processed data. And we can observe that we chose 1 to 40 to be the range of significant lags that we will apply in the CS. So the CS will determine which range is the best for the ANN. In here, we have the load data. In black, we have the original data. And in orange, again, we have the pre-processed data. In this case, it's different. As we can see in the right figure, the ACF of original and pre-processed data, we can see that it's different from the irradiance data. In here, we have two significant lags range. So we choose 1 to 40, the first range, and the second one, it is 150 to 186. For hidden layers, it will select a range of 1 to 60 neurons. And in this table, we have the results, the best results of the trial and error. In the left, you have the load results, and in the right, we have the irradiance. For example, in here, for the irradiance data, the best result based on trial and error, select 6 historical data for the ANN inputs. In this case, for example, for the irradiance, the trial and error select 1 to 6 historical data. And for hidden neuron, the best result was 40, and the MAP, it was 10.09%. If we see the second result, the second best result, based on trial and error, it was selected 1 to 6 historical data and 13 hidden neuron. And the MAP, it is similar. It is 10.10%. So you can see that the results in here are similar. And the second one presents a smaller amount of AN parameters. So when apply the Cuckoo search, they will choose the small amount, but he will observe the variation of the MAP. So in here, each optimization method was performed 20 times, and the best results are presented in table 2. So in here we have the results of Cuckoo search and the results of the PSO for the irradiance and the load. So here we apply the CS and PSO to select the AN parameters. And you can see here that the results are similar, but the Cuckoo search select some parameters better than the PSO. As for the simulation time, we have here, for the Irradiance data, trial and error, we got 24 hours and 52 minutes, PSO, just 2 hours and 42 minutes, and CS, it was 3 hours and 21 minutes. For the load data, trial and error, it was 36 days, 14 hours and 23 minutes. The PSO, 2 days, 18 hours and 46 minutes. And the Cuckoo search, it was 4 days, 16 hours and 52 minutes. In table 3, it is possible to observe the monthly map of the 24 hours ahead forecast of Irradiance and load. And we can see that we have the results of the Cuckoo search and the PSO for each month. And in the last line, we have the mean. And we can see that the mean of the Cuckoo search is better than the PSO. And here, we compare the results of this paper, the Cuckoo search results, with the reference 7 and 8. Both reference, it was the application of the same data, the same database, to forecast 24 hours ahead. But in this case, in reference 7 and 8, the NN parameters was based on ACF visualization and testing. So we can observe that this methodology presented lower error when compared with the reference 7 and 8 that use the same data, but select the parameters just based on visualization and testing, and do some testing in case. So you can see, for example, for the Irradiance data, this paper, we got 10.49%, and reference 7, it was 11.86%. And for the load data, this paper got 7.40%, and the reference 8, we got 7.95%. So for the conclusions, the modified CS optimization method ensured a good result for 2 time series with different behaviors, obtaining small amount of input data and hidden layer neurons. Moreover, it presented a significant reduction in simulation time to obtain these parameters when compared with the most applied methodology, the trial and error. In this case, the tests. So here, I have the reference that I used in this presentation. And thank you, everyone, for the attention.
Okay, thanks, Rafael. Please see the chat to see if there are any questions from the audience. If no question, I have a little one. That is, if you have made some tests on the dispersion of parameters of the network. Something like draw a set of samples, train the network, see the parameter, drop other set of samples, and do the same to measure the precision of the parameters of the network.
So about the NN that applied in here, I applied 20 times to verify the parameters. If the variation, as we can see here, as I can see here, I have the standard deviation values. So I can see that in 20 times, the variation was low. So I can see that the parameters that was selected are efficient.
Okay. The deviation in this sigma, in this the column sigma, is the deviation of the parameters.
Yes.
Okay. Thanks.